होने दे, मेरा चैन और करार मुझे खोने दे, बेचैन मैं रहूं सारी दुनिया को चैन से सोने दे। मैंने क्या किया अपनों के साथ, मैंने क्या किया, मैंने धोखा सबको ही है दिया, अपनों को हार के मैं जिया, तो क्या जिया, किस काम की है जीत, बस नाम की है जीत, नशा जाम की है जीत, सारा हराम भी है जीत। कि आज कोई दुआ करो मेरे लिए, कि आज कोई दुआ करो मेरे लिए, कि आज इस रात की कोई सुबह करो, कोई सुबह करो मेरे लिए।
As we discussed the main difference between permutations and combinations. Permutations is the number of arrangements, whereas combination is the number of selections. So permutation formula is NPR, combination is NCR. The difference is in NCR we have two factors, n minus r factorial and r factorial denominator. That is one thing. Second thing what we discussed is whenever we do something, the process, just say that in simple language, wherever and is there, it is multiplication, wherever or it is addition. See, selection of 3 boys and 2 girls. Selection of 3 boys and 2 girls means we have 3 boys and, so into 2 girls. Selection of 3 boys or 2 girls means 3 boys plus 2 girls. See, for example, selection. If you keep on coming, that's already 6 minutes over. You keep on coming, then that much time I have to waste. Yes, now, what do we say? Yeah. Number, if I have 2 pants and 3 shirts, total of how many ways I can wear? 2 pants and 3 shirts, wearing 2 pants and 3 shirts in different ways. So along with, it is 2 into 3. Why? Because the total possibilities with each pant, 3 shirts. So whereas 2 pants, if I'm saying 2 pants or 3 shirts, total of how many ways? 2 pants or 3 shirts means 2 pants can be wear in 2 ways, or 3 shirts means or 3, so it is 2 plus 3. So 2 pants or 3 shirts means 2 plus 3, or is 4 plus 2 pants and 3 shirts means 2 into 3. Same is in set theory, intersection and union. For intersection, it is multiplication and. So and stands for intersection or stands for union. And intersection or union. Same thing we will use in probability also. Wherever and comes, it is product into. Wherever or comes, it is plus addition. Anyway, coming to first question. The letters of the word don't tell. The given word, this is question number 1. The given word is BAUGHTER. The question, see that the question, it is not to, in all we have 1, 2, 3, 4, 5, 6, and 8. In all we have 8 letters. The question is not to arrange all these 8 letters. To arrange all these 8 letters, it is 8 factorial ways. So question is not to arrange all letters. Then how many letters to be arranged? We have to arrange how many letters? How many words means? So anyway, it is arrangement. So it is based on permutation. Question permutation is there because we have to form letters. Formation of words means it is arrangement of letters. So definitely it is permutation. But we don't have to arrange all these 8 letters. We have to arrange only 5 letters. Again, 5 letters means, is it any 5 letters? No. In this 5 letters, it is selection. That 5 letters we have to select. how to select? We have 2 vowels and 3 consonants. 2 vowels and 3 consonants. Here, how many vowels are there? We have A, U, E. These 3 vowels are there. 3 vowels. And consonants D, G, H, 5 consonants. So we have 3 vowels and 5 consonants are there. So 3 vowels and 5 consonants are already there in this given letter, given word. In that, from 3 vowels, we need to take only 2 vowels. So selection, that means we have a selection. See that we have a selection. Why? Because from 3 vowels, we don't have to take all 3. We have to take 2 vowels. And from the 5 consonants, 3 consonants. So first is the selection. These 2 vowels and 3 consonants are selected. It is not 2C3 ways. Again, see, this is the wrong expression. Why is it? Because in NCERT, the meaning of NCERT, from N things, R things can be selected. The selection of R things from N, we are selecting R. From 2, can we select 3 things? No. From 2 objects, we can never select 3 objects. Whereas from 3 objects, we can select 2 objects. That means out of, if you are giving an expression NCR, this R can never be more than N. So this expression is wrong because here R is more than N. That is wrong. 3C2 is correct. 3C3 also is possible. From 3 things, we can select all 3. But from 2 things, we cannot select 3. So 2C3 expression is wrong. So you are wrong. Part of your order. So 2 vowels. From 3 vowels, 2 can be selected. From 5 consonants, 3 can be selected. Then after selection, this how many letters did we select? We selected 2 plus 3, 5 letters. That 5 letters are to be arranged. 5 letters. So first is selection, then is arrangement. So this question is based on combination as well as permutation. Such questions are seen in examination. They are important questions. Questions based on permutation and combination. So from first one is selection. From 3 vowels. So write this. From 3 vowels, 2 can be selected in 3C2 ways. From 3 vowels, 2 can be selected in 3C2 ways. Then from 5 consonants, 3 can be selected in 5C3 ways. Then what? These selected 5 letters can be arranged in 5 factorial ways. See, first is selection, then it is arrangement. First is selection, then it is arrangement. So, therefore, total number of words is 3C2 into 5C3 into 5. Why is it into? Because we selected 2 vowels and 3 consonants and then we arranged it. So this process, if you are saying in simple language, in our mind, we can see that we use the connector and whenever and is used, it is multiplication. So 3C2 means 3 factorial by 3 minus 2, 1 factor, 2 factorial, 5 factorial by 5 minus 3, 2 factorial, 3 factorial, 5 factorial, 5, 3, 2, 1. Again, evaluation of this factorial. Denominator, you will see the smaller one. So it is 1 factorial, that is 1. Numerator, starting from this number, we will write as many factors, only 1 factor. Out of 22 is smaller, so 1, 2. So starting from 5, 2 factors, so 5 into 4. This is 120. This is so 10, 30, 12 is 3 to 6, 12 6 is 7. No, 5 to 10, 12 is 36. 360 and so 3,600. Again, 2 of you were there in the waiting room. Did you text in the group, sir? Please let me in, let me in. I'm not seeing the WhatsApp group now. When I start classes, I cannot see it. I don't see it. If you are in time within 3 minutes, then you will not be waiting for more than few seconds. I said it. Today also one of you, but he got the idea. He was waiting for more than 1 minute. Then he got the idea, he didn't write it. Yes, you have margin. Correct. This 5 factorial means it is 5p5 because that's right. Who wrote it? Shashank. 5 factorial. Actually, how come this 5 factorial? Because we are arranging it. How many letters are arranged? 5 letters. From how many letters? From 5 letters. From 5 letters, all can be arranged. Out of n things, r things can be arranged in npr base. Out of n things, all things can be arranged in npn base. So here 5p, 5 is. 5p5 is 5p5 is 5 factorial. So generally, out of n things, if all are arranged, it is in n factorial ways. We have a direct formula, n factorial. Now, question number 2. Again, how many words with or without meaning from the letters of the word? Question number 2. Letters of the word equation. The given word is EQUA equation. Here, the conditions. Here we have all letters of the word equation at a time, so that the vowels and consonants are two. So here we don't have any selection. Why we don't have any selection? Because it is given all letters are to be used. Whereas in the previous question, there was a selection because out of 3 vowels, only 2 vowels are to be taken. So we had a selection there. Whereas here, no selection because all letters are to be used. But with a condition. What's the condition? This vowels and consonants should be together. So how many vowels are there? E, U, A, I. Okay, 1, 2, 3. All 5 vowels are there. So A, E, I. This all vowels together in one box. Then how many consonants? Q, T, N. 5, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. 2 consonants. 3 consonants. So all vowels and consonants should be together. That means in the 2 boxes. These 2 boxes can be arranged in how many ways? 2 factorial ways. 2 factorial means 2 ways. This way or in this way, right? This box coming here. So these 2 things can be arranged in 2 factorial ways. This way or this way. These 2 boxes. Then within this box, this 5 letters, 5 vowels inside that box can be arranged in 5 factorial ways. These 3 consonants within the box can be arranged in 3 factorial ways. So total number of arrangement will be 2 factorial. 2 factorial means these 2 boxes into 5 factorial into 3 factorial. So draw this figure and write the answer. Draw the figure. Then write the answer. 5 vowels inside a box. 5 vowels inside a box and 3 consonants in another box. 5 vowels in a box and 3 consonants in another box. These 2 boxes can be arranged in 2 factorial ways. These two boxes can be arranged in 2 factorial ways. These 2 boxes can be arranged in 2 factorial ways. Next line. 5 vowels within the box. 5 vowels within the box can be arranged in 5 factorial ways. 5 vowels within the box can be arranged in 5 factorial ways. Comma, 3 consonants within the box. 3 consonants within the box can be arranged in 3 factorial ways. 3 factorial ways. Therefore, total number of words is equal to 2 factorial into 5 factorial into 3 factorial. Why into? Because this and this. This is 1 into 2, 1 into 2 into 3 into 4 into 5. 2, 126. 6 is 12, 12 is 144, and is next one. Question number 3, that's also a good question. So these types of questions are good. Question number 3 is again a good question, frequently seen. Such question, I hope you have completed. Again, someone. Question number 3. See here, a committee of 7 has to be formed from 9 boys and 4 girls with some condition. One is exact. So see, we have total 9 boys and 4 girls, so restriction 4 girls. We have 4 girls and 9 boys. 4 girls and 9 boys are there. First one, exactly 3 girls. Exactly 3 girls. See the total availability. Total we have 4 girls and 9 boys. We have 4 girls and 9 boys. We need to select 7 people. So from this 4 girls and 9 boys, we have to select 7 people. But we have a restriction. What's the restriction? Exactly 3 girls should be there. That means in our selection, out of the 7, exactly our selection, we need exactly 3 girls. Total of 7. In that total of 7, if we already took 3 girls, then how many boys should be there? Remaining, we need total of 7 people. Out of the 7, 3 girls we already took it because that is compulsory. Remaining 4 boys must be there. Then only 3 plus 4, in all 7 we select. In selection of 7, if we have 3 girls, then remaining 4 will be boys. That 4 boys are to be selected from 9 boys. So from 9 boys, so 3 girls and 4 boys. Again, how selection is possible? From 4 girls, 3 girls can be selected in 4C3 ways. And from 9 boys, 4 boys can be taken in 9C4 ways. So write it from 4G, 3 can be selected in 4C3 ways. From 9B, 9 boys, 4 can be selected in 9C4 ways. These, after selection, like in previous question, we don't have to go for any arrangement. Only selection is there. Therefore, total selection is 4C3 into 9C4. Why into 3 girls and 4 boys selected? So 4C3 is 4 factorial, 4 minus 3, 1 factorial, 3 factorial, 9 minus 4, 5 factorial, 4 factorial. Out of these two, smaller one is 1, so 1, numerator 4. Out of these two, smaller one is 4. So 1, 2, 3, 4. Numerator starting from 9, 9, 8, 7, 6. 4 2s are 8. 9 is 72, 2s are 144, right? So 144. No, 126. 9 sevens are 63, 2s are 126. 125 4s are 500, 594. Next one. Second bit, at least 3 girls. I hope you have completed. See, at least 3 girls. What's the meaning of at least 3 girls? At least 3 girls means 3 girls or more. Again, 3 girls or 3 or more. Wherever or comes, it is plus. Remember it. Wherever and is there, it is into multiplication. So here, now how the selection process can be done. Check it how this, and say that in simple language. How the selection process. We have total availability. What is the total availability? We have 4 girls and 9 boys. This is the total availability. Now our selection. At least 3 girls. At least 3 girls means 3G. And remaining 4 boys. 3 girls and 4 boys. So we selected 7. Is that all? No. All. Or it can be 4 girls and remaining 4 plus 3 boys. At least 3 girls means 5 girls not possible because why? Only we have 4 girls. Now see this one. And is here, or is here, and is here. So the total selection process. The total selection process is from 4 girls, 3 girls are selected, and 9 boys, 4 boys are selected. Or 4 girls, all 4 are selected, and 9 boys, 3 boys are selected. So from 4, 3 girls can be selected, and so write them from 4 girls. We are writing the total process from 4 girls. 3 can be selected in 4 C3 days. And from 9 boys, 4 can be selected in 9C4 days. Or the next option. This is the first option. 3 girls and 4 boys. So total of 3 plus 4, 7 is selected. Or what's the next option? From 4 girls, 4 can be selected in 4C4 days. And from 9 boys, 3 can be selected in 9C3 days. So our total selection in the examination, even if you are not writing this one, no problem. At least write this part. I hope you have commented. Therefore, total selection is therefore total selection is 4C3 into 9C4 plus 4C4 into 9C3. This one I think we did it earlier. 4C3 into 9C4. That was the previous one. It is 500. Was it 504? I think 504. I think is it? Yes, that was the previous one. 504 plus 4C4. 4C4 is 1. Why? NCN is 1. We learned from the NCN is 1. So 4C4 is 1. 9C3, 9 factorial, 9 minus 3. 6 factorial, 3 factorial. 504. Again, out of these two, 3 factorial. 1, 2, 3, smaller one. From 9, 9, 8, 7. 3, 3, 5, 7, 3 are 21, 4 are 84. So 5, 88. Next one, next bit, at most 3 girls. At most 3 girls. So at most 3 girls means maximum of 3 girls. Maximum of 3 girls, which is a possibility. Maximum of 3 girls means 3 or less. That means it can be 0 girls, no girls. It can be no girls, 1 girl, 2 girls, or 3 girls. So, from 4 girls, 0 girls, and all 7 boys. Or can be 0 girls and all 7 boys. Or it can be 1 girl and remaining 6 boys. Or it can be 2 girls and remaining 5 boys. Or it can be 3 girls and remaining 4 boys. Maximum of 3, not more than 3. So this is it. 3 girls, therefore total selection. From 4 girls, 0 girls can be selected in 4C0 into 9C7. 4 girls, 0 girls and 7 boys. Or plus 1 girl from 4. So 4C1 into 9C6. 1 girl and 6 boys. Or plus 2 girls. 2 girls from how many girls? From 4 girls. From 4 girls, 2 girls can be selected this way. And from 9 boys, 5 boys can be selected in 9C5 ways. Or from 4 girls, 3 girls can be selected in 4C3 ways. And from 9 boys, 4 boys can be selected in 9C4 ways. Simplify, do it as a home. Simplification, do it as a home. So this is another good question. This can be asked for 4 marks because we have different bits for this one. Attendance I will take in the next period. We have last period also. We have last period, so I will take the attendance in the last period. Anything else? So try this. Let me see. So 28 are there. Simplification, do it as a home. Anything else? So see you in the last period. Yeah. So we did question number 3. Now coming to question number 4. Question number 4. If the different permutations of all the letters of the word examination. So the given word is examination. Examination. So in this given word, if the word examination is listed as a dictionary, how many words are there in this list before the first word starting with E? We know that in dictionary, the words are arranged in such a way in alphabetical order. So these letters, if these letters were arranged, definitely it will start with A. After completing the letters starting with A, then we'll go for B. There is no B here. Next is C, no C. D, no D. E is there. So after A, after writing the words starting with A, the next letter will be the words starting with E, because there is no B, C, D here. Then after E, then E, F, G, H, I, J, K, L, M is there, then orderly it goes. Now, our question is, how many words are there before the words starting with E? Definitely, the words before the words starting with E are those words starting with A. So, our question is, how many words are there starting with A? That's the question. So, write it. The words before the word starting with E. The words before the word starting with E. The words before the word starting with E are those words starting with A. The words before the word starting with E are those words starting with A. See, in all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. The condition is starting with A. That means the first position is A. This is fixed. Remaining, how many positions are there? Remaining 10 positions, 10 places are there. In that 10 places, or this A is wrong. In that 10 places, do we have so total 10 places? In this 10 places, do we have any repeating letter? Can we say A as a repeating letter? No. Why not? Because out of these 2 A's, 1 A is already fixed. If 1 A is fixed, this A is gone. Remaining only this 1, 2. Remaining only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 letters have to be arranged because this A is gone. This A is already gone. We fixed it. Remaining only 10 letters. That is 10 places. In that 10 places, how many repeating? A is not repeating. E, no. 2 N and all this we have 2 N and 2 I's. So total number of words will be 10 factorial. So write it. Write it. The first place A is fixed. The first place A is fixed. the first place A is fixed. Remaining 10 letters. Remaining 10 letters. Remaining 10 letters, of which remaining 10 letters of which 2N and 2I. Remaining 10 letters of which 2N and 2I can be arranged in 10 factorial by 2 factorial into 2 factorial base, because that n factorial by p factorial. Out of n, if p are of the same kind, n factorial by p factorial. We learned it before. Therefore, total number of words is 10 factorial by 2 factorial, 10, 9, 8, 7, 6, 5, 4, 3, 2 by 1 and 2. 2 goes. Multiply, we get the answer. Next one. This multiplication, leave it as a home. Multiplication. Okay, 5, 6. 5, 6 are 30. 9, 8, 7. 72 to 7 into 2 into 30, then put 1 0. That's the answer. Multiply, you get the answer. Now, next one. Next one. How many 6-digit numbers can be formed? Question number 5. How many 6-digit numbers can be formed using the digits 0, 1, 2, 0, 1, 3, 5, 7, 9. 0, 1, 3, 5, 7, 9. 0, 1, 3, 5, 7, 9. The previous answer is 907 200. 2, 3 of you, I think 3 of you wrote the same answer, so maybe right. And 907 200. Hamza. Maybe it is correct. 907, that is the previous answer, correct. Multiply it, all of you get the answer. Yeah, now see here, someone is in waiting room. Tansil. This Tansil is a late comer always. He joined late and he's a late comer. Anyway, so here, how many 6-digit numbers can be formed from the digits 0, 1, 3, 5, 7, 9, which are divisible by 10? So in all, we have 1, 2, 3, 4, 5, 6. In all, we have to arrange 6 places, 6 digits. Nothing is repeated. So the 6 digits, again, do we have any restriction for any of the digits? It should be divisible by, yes, divisible by 10 means last place should be 0. So the last place is fixed with 0. If last place is fixed, remaining we have how many digits? 5 digits. That 5 digits can be arranged in how many ways? 5 factorial ways, right? Since the number is divisible by 10, since the number is divisible by 10, comma, the last place is fixed. The last place is fixed with 0. Last place is fixed with 0. remaining 5 digits can be arranged in 5 places. Remaining 5 digits can be arranged in 5 places in 5 factorial ways. See, 5 factorial is 5 ways. We discussed it, either NPN or n factorial, both are the same. N things can be arranged in from n things. From n things, all things can be arranged in NPN ways or n factorial ways. Therefore, total number of words is 5 factorial. 5, 4, 3, 2, 1. 120. Next one. If possible, we can complete this chapter today. I hope you have completed. Next one. The English alphabet has 5 vowels and 21 consonants. How many words with 2 different vowels and 2 different consonants can be formed? Words with 2 different vowels and again 2 vowels from 5 vowels, 2 consonants from the remaining 2 consonants. So first we selected that vowels and consonants. After selection, the selected 4 letters can be arranged in 4 factorial ways. So write it. Question number 6. Question number 6 is from 5 vowels, two can be selected in 5 C2 ways. From 5 vowels, 2 can be selected in 5 C2 ways. From 21 consonants, 2 can be selected in 21 C2 ways. Because first is selection, then what? These selected 4 letters. We selected 2 vowels and 2 consonants. These selected 4 letters can be arranged in 4 factorial ways. Therefore, total number of words is 5 C2, 21 C2, 4 factorial. 5 factorial, 5 minus 2, 3 factorial, 2 factorial. 21 factorial, 21 minus 2, 19 factorial, 2 factorial. 4, 3, 2, 1. Of these 2, smaller one is 2 factorial, 1 into 2, numerator 5 into 4. Smaller one 2, again 1 into 2, numerator 21, 20. 12 2 are 24. This is 10. So 10, 210, 24. 21, multiply 24 and 21. 24, 21, then put 2 zeros. That gives the answer. The main term, I will take that next. You multiply, I don't know, 20, 29, where they now 2 have gone. Yeah, 504, 2 zeros. Five zero four and 2 zeros. See the next question also. It's also based on permutations as well as combinations. Such questions are good questions. First is selection. 2 consonants and 2 vowels are selected. So it is combination. Then the selected 4 letters are arranged. So it is permutation. Next one. In an examination question paper consists of 12 questions divided into part 1, part 2, containing 5 and 7. A student is required to attempt 8 questions in all, selecting at least 3 from each part. Again, good question like that. Boys and girls, selection of boys and girls. So, question number 7. We have part 1, part 2. What is the total? Total part 1 and 2. Part 1 has 5 questions, part 2 has 7 questions. This is the total. Now, how that selection is possible? The selection, a student is required to attempt 8 questions in all. So, total of 8 questions he has to attempt. What's the condition? Total of 8 questions in all, selecting at least 3 from each part. At least 3 from each part. That means from part 1, at least 3. So starting from 3. So in part 1, if 3 questions are selected, and then from part 2, how many questions are to be taken? From part 1, yes, Amar, you are right. From part 1, if 3 questions are selected, definitely from part 2, 5 questions are selected. Is it? Because total of 8. Is the only option at all. He can select 4 questions from part 1. In that case, then 4 questions from part 2. Or he can select all 5 questions from part 1. In that case, 3 questions from. We don't have a next option because we cannot take 6 questions because only 5 questions. So these are the 3 options. Therefore, what is total selection? Therefore, total selection. 3 questions from how many? From 5. So from 5, this 3 can be selected in 5C3 and into from 7, 5 can be 7C5. It is same as that selection of boys and girls what we did before. Same thing. I am not writing in words. In examination, even if you are writing this way, no problem. So we selected from 5 points from part 1. 5 questions in part 1, we selected 3 and into. 7 questions from part 2, we selected 5, 7C5 or plus. Next option, we have to select 4 from 5, that is in 5C4 ways. Into 4 from 7, 7C4 or 5 from 5, 5C5 into remaining simplification, do it as a homework. Simplification, do it as a homework. So 5C3 is 5 minus 3, 2 factorial into 3 factorial, 7C5 is 7 minus 5, 2 factorial into 5 factorial plus 5C4 is 5 only. 5 minus 4. 7 factorial, 7 minus 4. Plus 5C5 is 1. 7 minus 3. 3, 5. 2 is smaller. 1 into 2. 5 into 4. 2 is smaller. 1 into 2. 7 into 6 plus. 1 is smaller. 3 is smaller. 1, 2, 3. 7, 6, 5. 3 is smaller. 1, 2, 3. Remaining simplification, do it as a homework. Next one. Question number 8. Yeah, what will be the answer? I don't know the answer. What the answer is? Multiple, I think 420. Ammar, you wrote 420 as the answer. Maybe. Simplify it. That is the question. Question number 8. Now, what simplification I am doing more. Question number 8. Again, number of 5-part combinations out of 52 cards. Exactly 1 king. Same thing. We did exactly 1. Hamza, you got 36960. I think Ammar got another answer. Ammar got another answer. So check your answer. Yes, okay. Okay. Now see question number 8. It is same as that A's question. We did that A's question. What is A's question? From 4 A's, 1 A's can be selected in 4 C1 ways. Remaining 40. So instead of A's, it is king. So it's a homework. Same thing. We did one A's question. From 4 A's, 1 A's can be selected in 4 C1 ways. Remaining 48 cards, 4 cards can be taken in 48 C2. So same thing here. Instead of A's, kings. So from 4 kings, 1 king can be selected in 4 C1 ways. So that's a homework. Now question number 9. It is required to see 5 men and 4 women in a room. 5 men and 4 women in a room. So even places. 5 men and 4 women in a row, so that The women occupy the even places. Even places means in all we have 1, 2, 3, 4, 5, 6, 7, 8, 9. In this one, we have 5 men and 4 women. That means here it is man, this is woman, man, woman, man. That's it. Now see, when women occupy even places. Even places means this one. This is even place. Second place, fourth place, sixth place, and eighth place. Even places means second place. This is question number 9 place. The second place, fourth, sixth, and eighth places. If you are right sitting in 1 to 9, the second, fourth, sixth, and eighth, they are even places. So these women are to be seated in these even places. So how many even places are there? 4 even places. How many women are there? 4 women. So these 4 women can occupy in 4 even places in how many ways? 4p4 ways. That is 4 factorial ways. Remaining 5 men can occupy the 5 odd places in 5p5 ways. So right, let's draw this one and write four women can occupy 4 even places. 4 women can occupy 4 even places in 4p4 ways. In all right, 4 factorial ways. That is better. In bracket 4p4. Because 4 women and 4 places. 4 women can occupy 4 even places in 4p4 ways. Remaining 5 men can occupy 5 odd places in 5 factorial ways. That is 5p5 ways. Therefore, chart, this is arrangement. Arrangement is 4 factorial into 4 factorial is 24 into multiply again. So 4 factorial is 24. 5 factorial 120 we came across many occasions. Next one. Yeah, Amar, you said 2880. Yes, 2880. Amar, Hamza, you all got 28. So 2880. Next one. Next one is an interesting question. We cannot complete this exercise, this chapter. I thought of completing it today. One question we left off. Question number 10. See, question number 10. We have 25 students in a class. In all, we have 25. From these 25 students, 10 are to be chosen for an excursion party. 10 are selected. So it is selection, not arrangement selection. 10 are to be selected. From 25, 10 can be selected in 25 CH9 ways. But we have a condition. What's the condition? 3 of the students, they have decided. If they are, even such friends are there, they will decide. In school also, you also do the same thing. Sometimes, if we announce some test paper, some of the close friends will decide, okay, tomorrow, both of us will not go. Both of us will fall sick tomorrow. Then both of them will not come. Otherwise, if one is ready, I go. Similarly, when we go for picnic also, same thing happens. If he goes, if those 3, my friends, the 4 friends are there, either 4 of them will go together or none of them will go. Exactly same here. 3 students, they have decided either they will go together or none of them will go. That means we have 2 options. If they are joining the excursion, they can join the excursion or they may not join. First option, see that only 10 students can go. First option, if 3 of them are joining, if all 3 are joining, then how many students are to be selected? That too from how many students? First option, 3 of them are joining. If 3 of them are joining, then do we have to select 10 students again? No. Why not? 3 already fixed, 3 already joined. Then remaining 10 students, we don't have to select 10 students. Then how many are to be selected? Only 7 are to be selected. Why 7? Because 3 are already there. Again, this selection of 7. This selection of 7, is it from the total 25? No. Why? From total 25, 3 are already there in the bus. 3 are already there in the vehicle. Those 3 occupied the seats. Remaining only 22 are there. From that 22, only 7 are to be selected. So if 3 are joining, then the selection is from remaining 22, that too only 7 are selected. So 22C7. This is one option. Or, so it will be plus. Second option, those 3 are not coming. If those 3 are not coming, now how many we have to select? We have to select all 10. Is it? Because 3 are there, not coming. We have to select all 10. Again, this all 10, that selection, is it from the whole 25? No. Why not? Those 3 are not coming. Those 3 already left out. Again, the selection is only from 22. From that 22, 10 are to be selected. So 22C, 10. So 22C7 plus 22C10. Write it. If that will do tomorrow. Anyway, 2. Anything else? Anything else? Nothing else. If one of you wrote, if what if 1 came? No. These 3 students, they have decided either all 3 will come or none of them will come. That they have decided. So we have only 2 options. Either all 3 will come or none of them will come. There is no question of only one among coming. There is no question of one because the question is given. They have decided all 3 will come or none of them will come. Anything else? So see you tomorrow. Tomorrow I will complete this. Again, how, Sayyid Qadri, how frequently should I practice maths? Depends on you. If you increase the number of frequencies are more better. Then Udu sir told that half yearly exam will be based on 50% MCQ and 50% descriptive. That is what is going most probably. In maths also, you have 80 marks. Out of 80 marks, 40 marks MCQ, 40 marks descriptive. It is not confirmed, most probably. So we'll see you next class.